Yo,
Hello, guys.
Evening.
Oh,
Yo, Fitz.
hello, Mary.
Hi,
Oh.
friends. Hi, Mary.
Why am I not included in that circle?
Loser.
It's because I'm a good friend. We'll start at like 7:30 something, or
Oh, Ian, is it okay if we start 7:35?
but
Yeah,
there's still
sure. Can you hear
13
me, by the way?
Yeah,
Yeah.
we can hear you.
Okay.
There's still like 13 people on the mute. Say you're drunk and I'm still confused. Still confused. Test. Oh.
Oh, could you give me access to share my screen?
Oh, yeah, sorry. Which one here? Is it good to?
The one with the profile picture.
This is good.
Okay, yep. Thank you. Man, chat does not sync with my phone for some reason. I have to like go back and get it back inside.
Oh, is it
Chat.
like delayed?
No, it's like it doesn't fetch the comments unless I go back and like refresh it manually.
Wow.
It's so weird. You can see the slides, right?
Yeah, we can see it, yeah. I
Alright,
would.
cool.
Yeah, we can see it.
Yeah. Um, 7:35. I guess we can start already. Ian.
No opening remarks.
Oh, evening, guys. I'll just yeah. So hope your evening's been fine so far. Yeah, this is our last tutorial of our web development workshop series. So, thank you for sticking with us all this time. And yeah, hope you enjoy this last one. So, Ian.
All right, so let's get started. So if you saw the Facebook post, this talk isn't very explicit on what it's going to be about, but by the name inbound relay, I think it means that how we're going to respond to messages that's going inbound to us and how we're going to relay that through our servers back to the user, right? So today our talk is going to be about web servers made easy with Node.js, a JavaScript runtime environment. So this is the topic coverage for tonight. So we're going to be talking about the background behind what is Node.js and all these other technologies. Then we're going to be discussing about the various terminologies that you might hear when you're, reading about Node.js topics. Then we're going to cover, the thing we missed out in all of our web dev classes, which is HTTP, the protocol that's used to talk in the internet, and then REST API architecture, which is the architecture that most of us follow. That's where CRUD came from. And then finally, we're going to be using Express.js, and we're going to be talking about it, the framework for making web servers, and how we're going to implement things inside it. And in the end, we're going to be having a demo where we're going to code. You're going to code with me to create a backend for a post application. So there's going to be CRUD functionalities, and it's going to be your typical REST API. So we're going to be doing that all tonight, and I hope everyone here enjoys. So let's get started with the background. So yeah, this is the end product that we expect to make. It's just a simple post app that you can create, read, update, and delete stuff, as you can see there. So yep, pretty simple. So hopefully we can do this by tonight, by 10 p.m. So without further ado, let's get started. So what is Node.js? So to the left, that's the logo. Node.js is an asynchronous JavaScript runtime environment, that's a mouthful, that allows computers to run JavaScript code outside web browsers. It allows developers to use JavaScript to write command line tools and for server-side scripting. So that first sentence over there must have been really hard to understand, but we're going to explain it eventually. So just keep that in mind. Asynchronous JavaScript runtime environment. That is the complex way of thinking it. But if you want to keep it simple, it's basically allowing you to run JavaScript code outside web browsers. So I think Brian has already covered this in depth in our first set of talks. You can probably watch the video if you missed that. But I'm going to assume that we already learned about Node.js, right? So why should we use Node.js for our backend server? So here are some pros and cons. But what I'd like to highlight, which is I think are the best pros of using Node.js, is that the ecosystem is huge and it's very diverse. So Node.js and all the technologies surrounding it are mostly open source technologies. So you could probably see the source code and all of its implementations inside GitHub. And the nice thing about this is that a lot of users can help contribute and they can help make more libraries to be used in Node.js. So that's why there's a lot of libraries that you can hear, like React, Angular, Axios, all these like common tools that we use are made by users that love Node.js and they want to build on top of it. So that's why the ecosystem is very big. So another benefit is that it's very fast. You might hear Node.js as a single-threaded, runtime environment. And thinking single-threaded versus multi-threaded, you might think that Node.js is slow, but in fact, it's not. It's quite performant, and at the same time, it keeps things simple. So you don't have to think about multiple threads. You just need to think about one thread, right? But there's some caveats there. We'll explain it later. And yeah, it's highly extensible. It's highly performant, and you could integrate it in almost every technology stack. And I'm pretty sure, like 99% of front-end development needs Node.js in some way, whether it is installing with NPM, whether it's building your application, you're going to be using Node.js eventually. And of course, there's seamless JSON support. So if you're not familiar with what JSON is, basically means JavaScript object notation. So the way we write JavaScript objects is mirrored in the way we write JSON, which is the data serialization format for sending data over the internet. So we could easily convert our JavaScript objects into JSON using Node.js. And of course, it's very easy to learn. So, and just to go on a tangent, yesterday I had a class in object-oriented programming, OOP, where we use C#, and holy crap, ASP.NET is so huge. So, it's a backend, or it's a full stack framework, and there's so much boilerplate just to make a simple web server to serve your HTML. And it was crazy. So when you look at Node.js, it's going to be so simple. It's just going to be like a single file. You could start doing so much things with it. And yeah, it's very easy to scale because it's just a single thread. You could scale it horizontally by using it on multiple servers and then using, load balancers like Nginx to, load balance your requests. And yes, it's very fast. If you want to develop an app super fast, use Node.js, use Express, use all of its libraries to your disposal. You can make an app so quickly, maybe in a day. So if you want fast prototyping, fast performance, and super simple, easy to learn ecosystem, then use Node.js. So I discussed this yesterday, last talk, and I think we've also discussed it in our previous talks. And yeah, so I'm not going to explain this that much, but the Node package manager basically allows us to install from the Node.js ecosystem using this command npm install the package name, and it's going to insert it in our package JSON, which we can then use in our projects by importing them. So I won't go too in-depth in this. We already know this. Just keep in mind that upper left command. It's very simple to remember. So in a nutshell, Node.js is used for server-side JavaScript because the browser, JavaScript was meant for the browser, but then people wanted to run it outside the browser because the syntax is so nice, it's very fast. So they placed it in Node.js. Then the nice thing about Node.js is that it handles concurrent events or asynchronous events very seamlessly using a single thread, using the event loop, which is why you call it an event-driven architecture. And the reason why it's called that is because this event loop, it's the one that delegates all the functionality, all the requests from the client, and distributes it to different processes, which it can then retrieve later. So I don't think I can explain it that easily right now, but basically it's like a circle of life, and if you throw something inside that circle, it will process it, and the next loop, it might not go back to you, but eventually it will, right? So when you throw things inside that circle, it's going to loop, do the process, and then go back to you. So that's basically how a single thread works. And the nice thing about it is that it doesn't have to do things in that loop like one by one, like in order. It could do one thing and then it's still doing it, so it's going to do some other thing inside that loop. So that's basically like a small idea about what the event loop is. But there's going to be like, I'm going to send resources later so you can read it on by yourself or watch a video about it, because it's a very unique concept in Node.js. And then, yeah, browser APIs don't work here, as I've stated earlier. The browser is very different from the server, right? So we don't have the window objects. So like window.reload is not available because it's just in the server. There's no window to reload. There's also no document object model. So document.query selector, that doesn't exist because the Node.js runtime just lets us use JavaScript code to write server code. So there's nothing to do with the browser here. There's no local storage for data persistence, but we can access more things which the browser can't, like file systems, the HTTP protocol library, and path names, right? So these are the libraries inside Node.js that's exclusive and not inside the browser, right? So here, this is what I was talking about, right? Like, what is non-blocking I/O? So typically, if you don't handle asynchronicity, or I don't know if that's the word, but yeah, look in the upper code sample. This is what happens when you don't handle asynchronity, or whatever the word is, to write your code. So the first line, const result equals db query. So this is SQL. You're trying to fetch from the database, right? So once we do that, we're going to be doing something with the result. So once it finishes, we'll do the result. But look, at line number 3, when we want to do something else after that, which doesn't rely on that result variable, it won't run because the first statement is pausing it. I mean, the second or the first statement is pausing it, and we can't, continue with our code. That's why it's being blocked. The execution stack is being blocked by lines number 1 and 2. But when we look at the code sample below, we're using a callback function, which is basically a function we pass into another function, right? Because the function that receives that function is going to execute the function, is going to execute the passed-in function, the callback, after it's done finishing its original purpose. So this original purpose is to select from post, select everything from the post table, and then execute the function that takes in the result to do something with the result. So if you want to read this in a sense that makes sense, to make it like sound more English, we want to, number 1, get a result when we do a DB query, and then run a function that does something with the result. And then, I mean, there's no and then. We just do that. We query and then we do something with the result. And then after that, after just like, putting that in the loop, the event loop, we want to do something else. So this do something else, we can do it without waiting for the result because we're just passing a callback function. It's basically saying, I want to do this later, so save me, right? So while it's still processing the query, we can do something else, which is the function in the bottom. So that's why Node.js is very nice. Callbacks lets us do asynchronous code later and not wait for the result of the code previously. So here, yeah, this is why it's nice. So let's say we have a lot of users in our application. So that's the users there on the left. And it's sending requests to the event queue, which goes to the event loop in Node.js. And then let's say a guy named John wants to read the database, but then a person named Mary wants to use the server calculator. So if John's going to make his request first, and if the database takes very long to respond, Mary is not going to get her like computation from the calculator, right? Because she's still waiting for the process of John to finish. So if we use Node.js and we use the asynchronous model with callback functions, we can just let Node.js say, hey, I'm going to do this thing that John asked, and then I'll do this thing Mary asked. And then eventually, John's request is going to finish. I'm going to send this result back, and Mary's like computation is going to finish, and I'll send it back. So that's basically why asynchronous functions and callbacks are very useful. So it lets us not wait for anyone else, and we can accommodate plenty users because multiple requests are being sent and processed at the same time via this event loop. So, wait a second, callback functions. What if I want a callback function to call a callback function, to call another callback function, and so on and so forth? So you're going to get this, right? This pyramid. You can see the little Ryu making a token there. When you have too many asynchronous events that rely on each other, and when you use callback functions, you get what is called in the JavaScript world callback hell, where we're waiting for a function to execute a function, to call this other function, to call another function, and so on and so forth, to eventually get the last function. So this is very ugly, and a lot of developers back in the day had to deal with this, and this is why a lot of people didn't like JavaScript at the time. But then eventually, I think with ES5 or ECMAScript, the standard of JavaScript, basically, they made a new API to handle this problem. It's called promises. So promises allow us to wait for asynchronous code and to write it, like top to bottom, just like previously. So, callbacks are useful if we want to, send something and to let it process later. But what if we want to block the callback function? So we use the promises API, the promise API. So you can see here before the word function, we use the word async. Async basically tells the JavaScript runtime to this function is going to run something asynchronous, so prepare to await eventually. So that's basically what the semantics is. So as you can see here, this is an async function called getPosts. It's going to await for a DB query, and it's going to await for the function to do something asynchronously with the result of that DB query. And then eventually, we're going to do something else with the result. So this do something else with the result will not execute unless the two await statements and their corresponding functions finish. So this is just what we did previously, right? So this is like the first example here. So if ever we want to do this, we do this. So there's going to be a lot of reasons why this is very important, but basically, let's say John's database, query is sent, right? We don't want to send something, we don't want to send something too early. We want to really wait for that database query. So we use this async await to do that. So in a nutshell, the event loop helps us do async functions. We can queue multiple tasks to be executed by a processor via this event loop in Node.js. And while it's executing, the event loop can still listen for more requests to be processed and queued later on. And once those requests are done, they are dequeued from the queue and sent back to the user. So the loop keeps going. Then callback functions, they're pretty good. They help us do asynchronous functions, but the Promise API makes it cleaner. So it lets us think of our code from top to bottom instead of like, this ugly mess. But, a lot of libraries nowadays didn't migrate to Promise yet. So if you're looking at code that looks like this, yeah, just think that the developers should probably update the code. But anyway, the Promise API is pretty good. You should use it. So that was the very simple basics of Node.js. And now I'm going to be talking about the best part of this talk, which is the entire year of your web development class that you missed, which is about the Hypertext Transfer Protocol, or HTTP. And basically, in a nutshell, HTTP is the laws that govern the World Wide Web. So if you don't know this, you're basically playing with fire and not knowing how fire works and how extinguishers can, delete fire or something like that. You're not playing with the right tools if you don't know how they work in the first place. So I'll be explaining that now. What is HTTP? HTTP is a network protocol. So a network protocol is a set of rules in networks, in computer networks, in computer-to-computer communication, right? So it's a set of rules for distributed, collaborative, hypermedia information systems. So just think of it as like, the World Wide Web. It's basically a network protocol for the World Wide Web that allows users to communicate data, right? So as you can see here, the picture in the bottom left, the Hypertext Transfer Protocol, this is what I want you to think when you think about it. It's basically where a client, typically a web browser or another server, makes a request on the network via the HTTP protocol. And that network in the internet, since it follows the rules of HTTP, it will successfully route it to another server, and which is typically a web server. And this web server has Node.js or some functions that execute on a successful request, which is then going to process in the server and then send back a response via the same HTTP protocol to send it back to the client. So this was HTTP was created by Tim Berners-Lee, the founder of the internet, because he wanted communication to be, standardized. Because if you're going to be communicating in English while someone communicates in Japanese, you're not going to be understanding that person in Japanese unless he speaks English, right? So that's basically what's the problem HTTP is trying to solve. We want everyone to speak English because it's the easiest way to get information across each other. And when everyone uses it, every server can talk to each other. So yeah, the people behind HTTP or like maintaining it and the standard is the World Wide Web Consortium. So if you want to read more about the laws of the web, you can go to their website and search about HTTP. So here's the HTTP in action, right? So this is I forgot what kind of diagram this is, but it basically shows the client on the left and the server on the right. So as you can see here, this is when you fetch a website, right? And a website, what does a website have? HTML, CSS, and JavaScript. So first, the browser is going to call the server to get the website, the HTML document. So they get the HTML document, then it loads it, and then they're going to see the link tag, right? Link rel style sheet, then the CSS file, right? Main.css. So the browser is going to say, hey, I don't have this file yet. Let me get it from the server again. So it sends another request from the server, then the server responds with the CSS file, and then the browser says, hey, yeah, I have the CSS file now. I'm going to display the body of the HTML, but now on the bottom, I see a script tag, and the script tag needs a JavaScript file. So I'm going to go to the server to ask for main.js, and the server is going to respond back with the JavaScript file. Then once the JavaScript file is received by the browser then executes the code in the JavaScript file inside the script tag. So let's say that that script tag fetches data, like after you load the website and you load the JavaScript, it says, hey, let's use Axios to get the data from the website, right? So it sends another request to the server, get example app /data.json, and then the server responds, right? And it gives it back to the browser. And now the browser can do everything with what it has, right? It can render the HTML, it can use the CSS, it can use the JavaScript, and it can use the data fetched by the server. So that's the typical, interaction between the browser and server when we use HTTP. And that's what's happening in the background. This is what it typically happens, but when we use React, it's very different. You just get the HTML and you just get the JavaScript, and the JavaScript loads everything else. So that's why when we talk about React, it's a very different paradigm. But this is basically the same model that we follow every time we think about HTTP. So as you saw earlier, we saw these get. What is a get? So in HTTP, the standard says that there are different verbs we can use to request from the server. So we know CRUD, right? We're very familiar with CRUD: create, read, update, and delete. And each of these letters has a corresponding HTTP verb. And if we don't use the proper HTTP verb, the server might be confused and not know what to do. So like, let's say we're trying to delete the post number 1, but then we use a get request. So we're saying get the device number 1. That's not right. I'm just going to return. The server's going to be like, hey, this guy's asking for the device number 1. I'll give it back to him. I'm not deleting anything. I don't need to. But then if the client says, hey, I want to delete device number 1, the server will say, hey, I see the HTTP verb. He wants to delete device number 1. So I'll do that. So that's why we use HTTP verbs. It basically lets the client communicate the intent to the server. So yep, every HTTP request should have an HTTP verb associated with it, because that's the rule of HTTP. We always have to put an HTTP verb, and it lets the server handle the request. So that was HTTP. That's a very simple model. It's a back and forth of the client and the server. But you can see on the right side, there's a word called RESTful. So I think you might have heard this before, REST APIs. So I'm going to be explaining that now. So REST APIs is how it's like a design pattern, or it's like a very common practice to do so that people will know what to do. It's not necessarily a standard, but it's a way of designing your application so that other people can use it easily. So it's like how you wear clothes, right? That's basically HTTP. You have to wear clothes or it's public indecency. But then there's a style of fashion on the current day and age that we use. So like, let's say white sneakers. You use white sneakers not because it's required, but a lot of people do it, and a lot of people can recognize you if you use white sneakers. So that's basically REST. REST is your white sneakers, and wearing clothes is your HTTP. So this is a lot, but the general consensus of what REST is that we organize our server endpoints or our URL routes as if they were just the resources themselves. So yeah, as you can see here in point 1, the URL of a resource should be like /notes. So if you have a server serving notes, you do /notes, and everything that follows that should be under the notes parent, right? So if you want to get the comments of a notes, you do /notes/comments. But if you have another server database, which is for the users, you do /users. You don't do /notes/users. That doesn't make sense. You do /users, and then you have more endpoints after that. So you always have this parent noun like notes user, which maps, or you can think of it as like your database tables, right? So that's what REST does. Then each endpoint has a unique identifier for each resource. So for each unique entry in your database, like in your notes database, you have note 1, note 2, note 3, note 4. That's going to be a slash. So /ID. So notes /1 corresponds to the note with ID 1 inside your notes database. And then in REST, you need to allow CRUD functionality, or you need to have like the capability to do so via HTTP. And then because of this, it lets your APIs or other people's APIs that you use to be very predictable and very compatible with other programming languages. So we're going to be talking about Node.js today, but you could design your API in REST, in the REST architecture, in other languages like Python, C#, Java. They all use the same standards if you follow the same architecture style, which is REST. So it's an architecture style. It's resource-based. So it's as you can see, you don't do /get post comments, right? You don't do /post/get post comments. That's like redundant because you're doing get /posts/get post comments. So there's like two gets. You can just do /get /posts, right? You don't. You have to map it in a way that it touches the resource. So we can do a post for a resource. So post/posts creates a new blog post. Get /post/id will get a post with the ID, or you can do get /posts, which gets all the posts. We can do a put posts then ID to update a post with a specific ID. Then a patch is similar to a post. A put, and then delete /post/id will delete a single post with the ID that's specified in the URL. So with REST, we allow our applications and other servers to communicate in a way that we can just visualize everything via the URL and via our HTTP verbs. So let's have a pop quiz because I need interactivity in my talk. So I'm going to ask you guys to type in the chat to help me formulate some REST endpoints, which we're going to be using in our application later. So our server is going to be hosted on http://localhost 3000/post. So this is our entry point. This is our resource, the post table. And I want us to get all the posts. So how do we complete this? Can any knowers in the chat say the full statement here? Any knowers? Just complete the statement, the question marks, replace that. Any knowers? So our choices here are get, put, post, delete, patch. Any knowers? Oh, full statement, guys. I'm asking for full statement. So a lot of people are saying get, but get what? You can't just send a request to your server to just say get. Get /post. Ivan, you have the right mindset, but our server is being hosted here. You see the URL there? So how do we write the code for that, or how do we write the request? Get from Lawrence. Here, Samuel. Get HTTP localhost 3000/post. So when we do that, we do this in the front end, right? We use a library to help us, connect to the backend. So we're going to await using a promise to get all the posts from our endpoint over here. So yes, you were correct, Samuel. So next, we're going to create a post. So what is the proper HTTP verb to create a post? Does anyone know? Any knowers? I have to refresh my chat manually, so there might be a delay. Philip says get. I wish get was a HTTP verb. There we go. From Philip. Congrats, Philip. Post. HTTP localhost 3000/post. No. Oh no. Oh my god. Okay, guys. This is supposed to be post. Sorry, this is my fault. Yeah, that's post. Post is correct. So post creates a resource, right, on this URL. So here you can see it on the code example. We have a function that accepts an object that has a title and content, and we do Axios post. So we make a post request on the base URL, which is the HTTP there, with the body, the contents of the post request to be parsed by the server. So yep, Philip, you are very correct, and I am very wrong in my slide. So now let's do delete. How do we delete a post? You can see on the left and the right side there are two sets of question marks. So how do we delete a post with ID number 1? Any knowers in the chat? Yo, Shane got it. So we do delete HTTP post, the base URL / the ID, which is 1. So yep, Shane, you're very correct. So as you can see here, it's just like a GET request, right? It's very simple, but instead of GET, we use delete. and we have to make an extension with the ID to delete the specific ID. So next, let us update a post with ID number 1. So I already showed the answer to this, but I hope someone else can do it. Any knowers in the chat? Lawrence, delete all? Delete asterisk? What? Drop database posts? No, guys, don't delete my database. Oh, Reese, put HTTP localhost 3000/post/1, and you are. Oh yeah, put is very correct. So it looks like a post request, as you can see here. But instead of post slash and then just the base URL, we have to put a /ID because we want to update a specific ID, right? A specific post with that ID. So it looks like a put request, a post request, but instead of post, it's put with a / then the ID. So congrats, guys. You are very smart, and I hope that your backends are going to be very fruitful in your web dev projects. So now that we're done with HTTP verbs, so HTTP verbs are the way of the client to send a message to the server to do something with the request. So how does the server talk back to the client? So the server talks back to the client via HTTP status codes. So I think everyone has seen this page before, the 404, right? The 404 is not some random number that they just arbitrarily placed. It's actually specified by the HTTP standard, right? So 404 basically means the resource is not found. So if you get /post, or if you put a post /1 and the server doesn't see a post with an ID 1, it's going to respond with a 404 saying the resource is not found. So HTTP status codes are numbers that describe the type of response that is returned by a server or an API. So it's the way of the server to communicate to the client. And it's very important for search engine optimization, right? Like the Google rankings, for an instance, try to traverse or try to request your websites via robots. So the way the robots understand what's happening to the requests is via HTTP status codes. And of course, other programmers, which is us, we want to know what's happening with our request and whether it's successful or not. So that's where the status codes come in. So these are the general classifications of status codes. So usually, you don't have to memorize all of this, but just keep in mind the categories, the big categories, and some specifics, some specific codes, which I'll show later. So personally, the first one, 100, the 100s are informational codes. The server acknowledges and is processing the request. I typically don't use this. I don't think I've ever used it in my applications. Then 200 is a very common category, which are success codes. So this like, hey, here's your request. It's successful, 200. So that's what we're going to be using for our success codes, 200. Then 300, we use this sometimes when, let's say we made a website on this URL, but then we want to place it somewhere else. So old people, like these robots, are going to be trying to checking the old URL. So they shouldn't get the URL, and they shouldn't get missing. They should get a 300 status code to redirect them to the new website. So that's the 300. We don't really use it that much unless we're like moving or migrating websites. Then 400 is a very common category that we're going to use, which is for client-side errors. So when the client sends, like, example, we want the server to accept a post, but then the client gives us like a picture of a cat. The server should be like, hey, what the heck is this? And respond to the 400, like 400 something, to say, hey, this is wrong. I need a post, not your data over here. So that's what the 400 is. Anything that happens due to the client or any error that is blamable on the client, you use a 400 category for it. And then if your server is still up and running, but the server doesn't know what to do, or the server, like the database connection is not yet successful, and you're trying to use that database, you should send back a response saying 500, the server is not working properly. So the client will know, it's not my fault. It's not my fault when I pushed the button, my server crashed. It's because of the server itself. So that's what the 500 is for. So those are the categories. And now we're going to be playing a game. So I think everyone loves memes here. So we're going to be guessing a status code based on cat memes. So I'm going to be showing a status code number and a picture of a cat doing something. And I want you to guess what does the status code mean semantically, or like a general idea of what it does. So here's the first one. Let's go. 200 OK. Can anyone guess what 200 OK does? Rest of the status 400 sends message skill issue. Just like me for real. Any knowers? Anyone wants to guess what does 200 mean? Success, success. Yes. So it's typically used for GET requests, and 200 means that the resource has been fetched and is transmitted in the message body. And if you've used Express before, or if you've used like basic Node.js stuff, and you do rest.json or rest.send, it typically just sends the 200 by default, because if you want to let the client know that you're successful in general, you use 200. So yep, very good. Thank you, Lawrence. So next, 201 created. Can anyone guess what that means? It's very hard. Any knowers? Successfully created. Wow, our very own lead. Thank you, Fitz. So yes, the 200 created status success code indicates that the resource or the request has succeeded and has led to the creation of a resource in our backend database. So the common use case of this is for a post request. So when something new is created, in like a post, we respond with 201 with a post, with our like new post, right? So now 204, no content. This is pretty hard. Any knowers in the chat? What is 204? So you can see from the meme there. They're waiting for something, but nothing is. There's no food in the bowl. Can anyone guess what 204 no content means? I'm manually refreshing. Any knowers? Come on. Even if the people have done this before. Has anyone used 204 before? Successful, but no content is fetched. That is very correct, Lian. So the HTTP 204 status means the request succeeded, but the client doesn't need to get anything back from the server, or it doesn't need to refresh the page or navigate away. So it's basically saying it's successfully deleted or updated. So we typically use this as a response to delete requests, to delete HTTP verbs, or put requests where we don't send data back. But if we do want to send data back, I think there's another HTTP code for it. So yeah, this typically means client, you're good, you've done your process, and nothing is being returned to you. So here, 403 forbidden. What does that mean? Does anyone know what forbidden is? That's a very fat cat. Any knowers? URL is a no-no. Technically, yes, because it's an error code. The URL was wrong, indeed. But why? What kind specifically? What kind of error was it? Successful but illegal to enter. I think we can accept that. I know, not successful. It's an error. Just illegal to enter. So yeah, the HTTP 403 forbidden response status code indicates that the server understands the request, but refuses to authorize it. So it's like saying, I want to get Samuel's dirty secrets. So at Samuel/Bonganoy/secrets. But I'm logged in as Ian De Jesus. I can't access Samuel's dirty secrets unless he gives me the lover permission. So unless I have the lover permission, I can't access it, and I'm just going to get a 403 error. But if I have the lover permission, I'll get a 200 because I'm successful. So right, so you do 403 when your authentication system wants people to not access things. What dirty secrets? Oh, Sam, you know. Anyway, what is 403? Bad request. This is a pretty useful one. 404. Nice one. Does anyone know what the 404 bad request means? I mean, technically, every 404, every 400 is a bad request. But what does a 400 do? Incomplete? Something is missing sa request? Possibly. Actually, I forgot. So if someone like says something pretty good, then I'll probably check. So one more answer, then I'll check. Any knowers? Any guessers? Client error. Oh, yes, correct, Lawrence, technically. Internal server error. No, not exactly, Shane. Let's check. So bad request indicates that server cannot or will not process the request due to something to be a client error. It was the client's fault, not mine. So basically, we use this in general if we don't use the others, right? If we don't use forbidden, if we don't use the 404, and we know that it's the client's fault, and we don't know the HTTP status code. This is basically our default that we want to use, so that at least the client will know that it's his fault in general. So this is basically like a catch-all. If you don't know what to use, just use this if it's a client's fault, right? But I'm pretty sure if you have a specific error, you should check out the 400 category more before using the 400. So yeah, that's basically the 400. It's like a Swiss Army knife for client errors. So yeah, this one, well, I'm pretty sure everyone knows. So first one to chat, get something special, I think. What does 404 not found mean? The specific statement. I want the proper keywords in your answer. Server error? No, no, no. 404 means client error, or like 400. Data can't be reached, but why? Why can't the data be reached? Why specifically? Page not found? Not necessarily pages. Very close, but page is not the right word. What is the specific word in terms of HTTP and REST APIs? The requested data. What is requested data when it comes to REST APIs? What is requested data? Any knowers? I said it earlier. It's in the name of REST. Actually, no, it's not. Server not found? No, no, not yet. It's not the server's fault. It's the client's fault. Or yeah, it's the client's fault, I think. Client request not found. State. Oh, very close. State. Or what do you call a database entry? What is a database entry? Requested server not found? No, not really, because you can do / the server, it'll still work, but if you do a specific thing in the server, it'll 404. So the server's still there, but something blank is not there. Okay, I think you have the right idea, guys, but the specific term is resource. So yeah, it indicates that the resource is missing, not necessarily a page. It could be a JSON file. So it's specific. It basically has it's like a catch-all for saying it's missing, but it doesn't indicate whether it's temporary or a permanent. So if the resource is permanently removed, we use 410 instead. So there are very specific edge cases, and they have very specific status codes. But if you want to just say the thing is not there, just do 404. So nice. This is our last one, I think. 500. Any knowers? I think it's pretty easy. What is 500 for? So to recap just quickly, 100 is for information, 200 is for client success, 300 is for redirection, 400 is for client error, 500 is what? What are we missing from the puzzle? Server crash. I don't know what happens if a server crashes and it can't respond, because typically we use this for responses. So I'm not sure, but maybe that's correct. Depends on your infrastructure as a code or infrastructure, cloud infrastructure. Server is guilty. Oh yes, I think we can accept that. So yes, it is 500 is for server errors, and 500 is like our 400. 400, right, is a catch-all for client errors. So 500 is a catch-all or a Swiss Army knife for server errors. So like, let's say you're trying to connect to MongoDB, but your MongoDB connection password is wrong. So your server's still running, but it's always sending the 500 status codes, and it's going to probably say like MongoDB is down. So yeah, it's the server's fault, not the client, because we have to distinguish whether it's the client's fault or the server's fault, so that the client or whoever is trying to talk to the server knows that it's knows when to try later or to try again, right? So they try again if it's a client error, which is 400, or they try later if it's a server fault by 500. So yep, Thank you for playing my game. Those are HTTP codes. And if you want to see all the other HTTP codes, you can go to HTTP cat. So now let's get to the meat. So now that we've discussed, just to recap, we discussed HTTP, which is the laws governing the internet. We talked about HTTP verbs. We talked about HTTP status codes so that we can communicate. And now we also talked about, REST servers and how they're made with Node.js to respond to client requests. So now let's get to the implementation on how to make a server with Express.js. So Express.js is an unopinionated, quick, and easy way to create web servers. So this is where the fast prototyping comes in, or the fast development. So what is Express.js? Just to keep it simple, it's a lightweight framework. It's very light. It doesn't have many dependencies. And we can install it using npm install express. And it allows us to abstract intricate details of Node.js normally. So like what I've stated earlier, Node.js has a file system module, path module. It has an HTTP library, but it's very, very boilerplatey to use those libraries. So Express was like, hey, I'm a very lazy developer. I want to just, describe my intent, and I'm going to create the functions that do that automatically for me, and they call these other libraries for me. So that's what Express is. It's basically a lazy programmer's child to make web server programming very easy. So yeah, it's a web server framework, and it abstracts routing, middleware functions, file serving, HTTP request parsing, which was like the HTTP verbs, then HTML templating, so we can serve websites with our web server, and many more. And of course, since it's very lightweight, it's basically a blank canvas. You can build so many things on top of Express.js, not just web servers. You could make your file server, you could make a streaming server, you could make like a remote control, just using Express.js, and you can make it connect in your local network. So it's very flexible, very useful. But today we're going to be using it for our web framework to respond to our React front end. So yep, that's what we're going to be doing for today. We're going to have a live demo of me programming an Express server to talk to React. So remember this thing I showed in the start of the talk. So we want to make CRUD functionalities with our front end. So our front end's React here. So we can make CRUD, we can make edits to our code, to our posts. So this is a post application, and we're going to be making that. So I have a repository online if you want to follow along. So I'm going to send the link, or if someone else can. Wait, hold up. Oh, 1 second. Can anyone send in the chat who's available right now? Wait, let me dig it. I'm going to dig. It has all the instructions in that repository if you want to play around and code along. Here you go. I sent it in the chat. So if anyone wants to code along, it's on the repository. So yep, you just do these things. You clone it, you go inside it, you check out the start, and you go inside the client to install the packages for the front end. So I made the front end already for us. All we're doing is just the back end. Oh God, it did not save my other slide. So yeah, we're going to be doing this. Our tech stack is React. Wait, let me share my screen. Okay, see my screen. So our front end is React, and our back end is Express. And we're going to be making a post website. So let's try checking out the cloned repo by itself. So this is the cloned repo. If you clone it, you're going to get this. Then when you get checkout 0 start, you're going to be here in this directory. So you can see, as you can see here, the server is empty right now. There's nothing there, but the client is very full. So this is a Vite app. It's a Vite React app, and it has all the basic stuff, right? So this the main part is our config over here. So we don't really need to look at this. We have to look at the SRC though. So as you can see here, it's a post application. So wait, let me just run it. npm run dev. You joke. CD client first. So now we're in the client. Then npm run dev. Right. So if we look at it here, we go inside. It's called inbound relay. Very original, right? Here, look, we can see it's loading, but oh no, something went wrong. It seems your backend has issues. Check the logs for more information. So, oh, look, you can toggle the light mode. Check out the backend. Let's see the logs. Axios error. Failed to load resource. Connection refused. Let's see what's it in depth. So as you can see here, error result request. So yeah, I think it means that our backend is not working. So I don't know where you can find the specific status code, but it should be a 500 somewhere. Yeah, basta. It's a 500, something 500. So if you can see in the instructions on the slides, it says you have to do npm run the, mock also. So if you look at our package.json, mock runs a JSON server, which is basically a test database for us, which mirrors what we're going to implement eventually. So let's just run mock, npm run mock. So this should run JSON server, which is a library, to make a server, a database, based on a JSON file. So this is our database. As you can see here, it's now listening to 3000. So if we go to 3000, it should return everything in this list. Wait, what? Nothing? Nothing? Wait. Oh, no, because I have to do /post. Because remember, just going here is the server, but /post is the stuff. Yeah, you have to get /post, not the server. So now that we confirm that it's working, let's go back to our app and refresh. Ooh, it fetched everything and displayed them. So that's very cool. Let's check if it works. So let's create a post. So I love Starfire. My God, please marry me. So we post that. Boom, it refreshes the page and it goes here. And if we check our db.json, you can see it modified. And it's over here. So ID 6. So then if we edit it, I love Samuel Bong Hanoi /DSA practice. I want 1.0 in DSA, please. It refreshes and we can update stuff. So the JSON server is doing all of that. And let's try deleting it just to check it out. Yeah, so we can do CRUD. We can create a post and we can render everything in our website. So that's very cool. But I don't want to rely on this. Like, what if I want to rely on MongoDB? What if I want to rely on, Redis? What if I want to rely on any other backend, like database? I don't want to just rely on this. So let's abstract everything to a server. So as we're going back to the app. This is the app, very basic. The nav bar, the posts, and the footer. So that's basically it. The nav bar, posts, and the footer. And then if we look at the post grid, don't look at the other code, but all we're doing here is we're fetching the posts from the backend, which calls post service get posts. So if we look at post service, it's from our services directory. So if we go back here, services, our post service. So here, it's basically getting posts using this. So that's the Axios thing I showed you earlier. So we're getting posts from localhost 3000 /post. So I want to not use JSON server because right now it's using JSON server. So I want to implement all of the functionality with Express. So let's get started. So we're going to use this as a baseline to implement our API in Express. So first, when you're making a new Express project, wait, I'm going to close the application for now. Or I'm just going to close the JSON server because we're not going to be using the JSON server anymore. So it's going to error again. So loading, then it's going to time out, then something went wrong. So now let's go to our server. So cd up. So now we're in the root of our project, cd server. So now we're in server, right? So to make it more obvious, let's go inside it. So right now we're in server, and server is very empty. Foreign land. What do we do when we have foreign land? We colonize it with npm init-y. npm init-y will make your base package JSON configuration, so we can install things later. So boom, there we go. So now that we have that, we can do npm install express, which is our framework for web servers. To give it some time. So there, very cool. We can see now that we have Express. So when we do, what's our entry point? Index.js. Actually, yeah, just stick with that. Index.js. So when we do this, const app equals require express. So we're importing from the Express library. I think we can go to it actually. Yeah, this is it. So it's exporting that, and it's going into app. And then let's specify the port that we want to listen to. So port equals, like, let's see, look at the front end again. So we want to go set up a port here, 3000. So that's our port. Then we do app.listen. .listen, our port. So app.listen will make the server listen to any requests on the current computer at a specific port. And once that's done creating the request, it's going to make a callback function, which executes eventually after the first thing is done. So it's going to console log server is now running on http://localhost 3000. So there. So now when we run our application with, or when we do node index.js, oh, app.listen. Wait. Oh, no. Wait, my bad. Express. Okay, wait. It exports express. Then const app equals express. Yeah, to instantiate it. My bad. So we do that, and we run node again, node.js. There we go. So now it's listening. So right now, our server is listening, but when we go to it, error, cannot get. Because we did not make a function that responds to any GET request on slash, which is the root, which is this. So we're trying to get this, but nothing's returning. So let us respond, right? Let's make a request handler. That's the term. So app.get. So we do app.the type of HTTP verb, and then the URL path, which is slash. And we make a callback function that accepts a request object, which is the HTTP request data, and a response object, which we're going to use to communicate back to the client. So wait, just checking again. Yep. So app.get. So rest.send. So for now, let's just make it send. Oops. Send an h1 that says hello world. Now we do this. We want our application to respond by sending a response that is an HTML hello world. What did they do? I think it's supposed to be a string. Oh no, I did not refresh. Okay. So yeah, very annoying, right? I can't refresh. I have to run it again. So, oh, unexpected token. Yeah, it's a string supposedly. So here's the problem when you're developing without any libraries, right? When you have to keep running your application again and again. And now it works, right? Now it works because I refreshed it. So it's very kapoy, but a developer had the same problem as me and made a library for it. So there's something called nodemon, which automatically refreshes your code every time you make a change and save it. So npm install nodemon, then we'll save dev. We don't need this, but I'm just doing this. Save dev means we'll install it as a development dependency. So when we build our application, it won't save nodemon in it. It only save express. Nodemon's just used for development purposes. So now that we have nodemon, when we do nodemon index.js, look, it's now, oh, what the new error? I mean, new version, weird. So yeah, it's now watching everything with JS in its file name, right? So when I save here, right, hello world is working. So yeah, I just refreshed and still hello world. Hello Sam, smiley face. Oh, I saved it and it ran again. So restarting due to changes, starting node index.js. We go here, refresh, hello Sam, smiley face. So very cool. So that's nodemon. So to make it even more convenient for me, I want to make a script that will run that. So that's where node scripts, npm scripts come in. So dev, I want to run nodemon index.js. So now that I have that, I don't need to type nodemon index.js anymore. I just need to do npm run the script name in the package.json. So npm run dev. So it runs nodemon index.js. Yep, as you can see here. So now we have a pretty cool development environment where we don't have to keep refreshing. So let's get to the meat. So when we're in Express, we have a specific, we're making a REST API. That's our goal, right? But how do we model our REST API, or like how do we model our code so that we don't get stuck in, infinite lines of JavaScript code in one file? We want to separate our code into different folders, into different files. So there's something called Model View Controller, MVC. It is a framework or a way of thinking and architecting applications where we have our model, which is our database, our view, which is our website, and our controller, which is our functions. So every time the website or the view talks to the server, it's going to call a controller, which will then call the database. The database will then go back to the controller and send the response back to the view. So that's our architecture. And we want, since our front end is already doing the view, we don't need to think about that. We just need to make our controller and our model. So let's go here. So let's make a folder called model. Let's make a folder called controller. Actually, it's supposed to be plural. That's like the convention, I think. So models and controller. So since our app is pretty bare bones, our model will be post.model.js. It doesn't have to end with model.js. I'm just doing that because it makes it more obvious when I'm importing stuff. So I'm going to make a post model, which is an object which has posts, which is this. It's an array, right? So we're going to do module.exports equals post model. So our post model is just an object that has a posts, which is a array. So I'll just call it state. So that's very cool. So now let's go to our controllers and let's make a post.controller.js. So controllers are functions that respond to, client requests. So first, actually, before making a controller, we want to describe what our endpoints are, right? So that's called a route, or a route is interchangeable with endpoint. So we're going to have a routes folder for post/route/js. Then we're going to we're going to have a router, which is an express router. So instead of doing app.get, we can do router.get to get all of our posts. So callback of request and response. And then in our post routes, we want to use a controller to get it, right? So wait, we're going to module.exports equals router, because we're going to import it later. So to use our router, after setting up all our stuff, we go back here in our app and we const our post router equals require. Oops, where am I? Why is it going up? Oh wait, no, it's going up. Sorry. Routes/post routes. So that is requiring our post router, which we exported here. So now when we do use app.use post router on every /post. Every time we use basically means every time we go to an endpoint specified here, we want to call this middleware function. So our router is basically just a middleware function, and middleware functions basically like intercept code. So it's like if this is the client and this is the server, and yeah, before we go to our get function, we go through middleware. So middleware is like a filter, which takes in your request, these things, processes them before sending it to the get. So before sending it to the get, I want to use a post router middleware function. So that's what middleware is. Middleware. So middleware is just a filter that will do stuff with the res, the rec, and the res before sending it to the endpoints. So now we're using a post router, and we're going to, every time we hit the post endpoint, we want to trigger the post router. So here, when we do /post, we want to make a get request. So let's test it out right now. Res.send h1. I'm in post. Oops. I'm in post. H1. So this should work. When we hit the post, just the post, we should get this. I'm in post. Let's see if that works. There we go. It works. So that's what middleware functions do, and that's what routers do. So now we don't have to worry about writing post and post all the time in all our routes. We just need to make a middleware function that triggers on post to then call the post router to process the stuff. So let's go and let's see what our client needs. So we're now talking to this. So we need a get, a post, a delete, and a put. So those are all valid endpoints that we can do here. So in the get, so we have get here. We have a post, so router post, /a post, rec, res. There's our res.send. Just for now, I'm just gonna, I'm in post, I'm in post, I'm in get post. Oops. In get post, I'm in postception, and I need a delete. I'm in delete post, not delete by itself, but with a /id. So post /id, and then I need a put. So a put, and it also needs an ID. So I'm in put ID. So now to test these things, we can't do it on the browser because browsers, by default, when we put a URL, it only sends a GET request. So we need an HTTP client for that. So in VS Code, there's a very cool one called REST client that I use more often than Postman, right? So this is the one. So when you install it, you have access to cool things called REST files. So request, I'll make a request folder with get post .rest. So anything with .rest allows the plugin to take action. So now we're going to do HTTP. So you can see here, send request. And now we can write our HTTP requests. So /localhost 3000/post. So once we do this, we're expecting I'm in get post to respond. There, HTTP 200. OK, I'm in get post. But right, so that begs the question, right? 200. Why is it 200 by itself? I didn't specify that. So by default, when we do .send or .json, it'll automatically send the 200 request. I mean the 200 status code. If we want to change that, we can chain the res object with .status. Then an integer is the parameter for the status code. So what if we want 404? Oh, that's weird. This should respond with 404. Oh, not found, but something responded. See, this is possible, but it's not RESTful. So our REST API expects for 404 to return nothing. It should just say error and not return any data. So yeah, if you want to change the status code, just do .status and then the status code, right? Like so, like that. So now that we have that out of the way, I want to make the GET request respond with everything inside my model here. So my post controller is going to import the post no, import is not allowed here. Use const. So post model equals require upper directory, go inside models / post model. So as you can see here, that's our post controller. Const post controller equals object. Then module.export equals post controller. Wait. This is a JavaScript pattern called the module pattern, where I immediately execute a function that will return an object so that I can have state inside this. So I don't necessarily need my post model actually. So okay, never mind. We won't have a model for now. We'll just have our post controller. So our post controller will have the current state or posts equals array. So we have that. And now our post controller should only expose the functions needed to communicate with our model or our database. So this is our database. We want to make a get posts controller function. So when we call this, we want to asynchronously, just to mimic how normal servers do it. Or okay, let's not do that yet. Okay, never mind. Let's just do that. Just to make it look legit. So we want to asynchronously await something. I don't know. I'll just make it async but we're not using await. So we're just going to return posts. So our get posts when called asynchronously is going to get it's just going to return this array. So we're going to expose that. So our post controller is exposing this get post. So when we import the post controller, we can do post controller.getPosts. So let's try that now. So we're here, we're in our routes, our post route. So let's const post controller equals require controllers / post controller. So when we're here, we need to make an asynchronous function now because our function is asynchronous. So since one thing is asynchronous, the upper thing has to be asynchronous, just like callback hell. So we do await, const let's just call posts equals post. We need to await because we need to await every asynchronous function. Await post controller dot get posts takes in nothing, and we want to send that post back as a JSON. So the nice thing about this is you don't have to do send all the time. You can do JSON, and it will implicitly convert your parameter into a JSON format, which will then send it via HTTP. So we do that. So it should 200. So just to make it explicit, we'll do status 200. So this should be get OK if it exists. So if we go here, there we go. That is our array right now. So just to make it let it mimic the real thing, let us copy the DB over here. So the nice thing about JSON is it's just JavaScript object. So this is a JavaScript object that has a post property, which has an array. So this array is our state. So let's just copy our state. And let's put it here. Hello state. So now if we do the thing again, boom, should show our JSON. So very cool, very cool. That's our state. So if we want to mutate the state, or if we want to change the state, we need to expose another post function in the post controller. So wait, this is kind of messy. I'm going to commit something sacrilegious. Sacrilegious with a var. So data. Oh God, forgive me. Data. So this works because it does not work. It crashed. Oops, const is not a valid keyword. Where did I put that? Const get post unexpected token. What? Okay, it's not happy with me, so I'm just gonna go back to the state where it was. Right. So if someone beats you up when you do something good, if someone bullies you, you should probably rethink your life decisions. So never mind. That was too complex. I won't do that na lang. So yeah, that's a big blot of code that we have there, but we'll just deal with it. So const what do we want again? We want a post. The post should accept, let's go back to our front end. The post should accept title and content in the body. So let's just do that here. So here we have a const create post, which will asynchronously take in a title and content, and it's going to insert it here in our database. So posts dot, was it push? This push adds it to the end of the array. Okay, it's going to add it here. So push is going to add, oh no, our ID. We need a ID. Interesting. Okay. So I'm going to have another variable. Let next ID equals, or let's say current ID equals 5. So this is our counter to keep track of what our current ID is. So we're going to push a new post with an ID, which is current ID plus plus. The plus plus there is so that we can increment the current ID to become 6 after we add it. So current ID title and content. So when we create the post, we're going to push that thing, this new post. And once we're done, we just want to return the new post just for simplicity. So now we're going to expose our create post function. So now we can use create post, which is an async function. So let's do that here. So now the question is, how do we extract data that's being passed in by the client, right? Because as we can see here in our post, we're actually passing an object, right, as JSON. Because when we're communicating via HTTP, we can't pass like objects as themselves. We need to turn them into something else, like plain text. But in our case, we can use the JSON format, which is a plain text format, which like it arranges your plain text to look like JavaScript objects, so that we can easily parse them later. So to do that, let's make a new request, which is post. Oh, that's weird. Post.rest, or let's just call it create post. Create post. So we want to make a post request on our base URL, just mirroring the front end, right? So we're creating a post on the base URL, and we want to send a content type application/JSON. So this is an HTTP header to give the HTTP request more information so that the server can process it more easily. So we're going to pass in a JSON object. So for example, we want to pass in a title of test title, I love GDSC. And then we're going to make content and something random. And this is a valid request. So when we make a post request, we're going to send it there, but then we're only going to get this back, right? We're going to get I'm in post/post. So that's what we're expecting. So yep, I'm in post/post. So even though we sent application JSON, or like even though we sent a JSON object, we're not really parsing it, right? Unless we let the server do it, unless we let the server process it. So let's process it right here. So just to show this more explicitly, so when we do request, or let's do object.keys request, right? So when we do that, when we send our create post again, we're going to console log the keys or the properties of the request object. Let's do that. So let's look at it here. So this is the array of all the properties of our REST object. So oh my gosh, there is a lot. But what we're interested here is the body. If I can find it, the body is not here because in Express, it won't accept bodies unless we tell it to. So to do that, we need to use a middleware function to parse our body, our JSON body. So we need to do app.use express.json. So yep. So now it's going to parse our stuff. So yep, returns a middleware that only parses JSON and only looks at requests where the content type header matches the type option, the content type being application/JSON. So now that we have this, the middleware is going to read the string, which is our string here, and it's going to turn it into a JavaScript object called body and append it into our request object, right? So now when we do this, we're now expecting the body to be present in our keys. So let's do that now. Create, oops, what is happening? Why can't I click it? Click. So now our body should be here, so that it still works. But here we go. Our body is now present. So when we console log that body now, let us console log request.body. Let us make the request again. So, oh my gosh, it is our thingy we wrote. It's here. It's now our JavaScript object. So if we do type of inside just to check if it's really a JavaScript object, so type of. Is it a JavaScript object? It is a JavaScript object. So it automatically converts your JavaScript object via this middleware, Express.js. So now that we have that, very cool, we can now const the post data, which is title and content equals request.body. So this is a destructuring statement. So given this object, we want to extract these properties and assign them into the title and content variables. So now that we have that, we can do title and content. So this should print out the stuff that we were sending. So boom, yep, it's there. So now that we have that and we can access it, we can now use it in our controller, which will create a post given a title and content object. So now that we have a title and content object, we're now going to do const. So this, remember, this returns the new post that we created. So new post equals await post controller. So look, your IntelliSense knows that your create post exists for the title and content. And oh no, squiggly lines, what's happening? Await expressions are only allowed in asynchronous functions. So don't forget, we have to make it async. So now we have a new post. We just want to see if it's sending it back. So that's JSON, our new post. So when we create post, it should work. So there we go. This is our newly created post. Why does it have an ID of 5? That is not right. OK, this should be incremented. Oh no, what is this? It's incrementing it twice. That is not good. I should increment it beforehand so that it can be 6, and then it will insert. OK. OK. There you go. So now that that's fixed, it should return a 6. So if I restart my server, it should restart the state. And boom, it's 6 now. Yeah, very cool. Now if we do it again, it should make 7. Very cool. Now that that's working, that's our post request. But remember, since we're making a REST API, we need to put the proper status code. So what is the proper status code for making a post request and successfully posting it? Does anyone know? Any knowers in the chat? So what is the status code? It should be a success because it's 200. Any knowers in the chat know the correct status code? Server there. Just check the chat now. What is the correct status code when we create a new post? It's 200. But what? What kind of 200? We discussed it earlier. Does any knowers in the chat? 201, very correct. So that means resource is created or successfully created, and then we're going to return that new resource. So let's see here, boom. So yep, very cool, 201 created. So there we go, that's our created object. So now that we're done with that, we're done with this one, create post. We're now going to do delete post. So wait, just to see if our backend is actually working, let's try testing it with our front end. So our front end, let's restart our front end just to see from square one. So yeah, it's not working now. So let's npm run dev. So boom, it's here in this URL. So we refresh. Something went wrong. Interesting. It should work. Let me check my console. OK, I think the problem is my thingy. Wait, this should work, right? This works, but that's not. So when that happens, typically what you should do is you use cross-origin resource sharing, which is a library. So if npm install course, because right now I think this only listens to things inside its own port. So if we have things from other ports, it won't listen to it unless we specify it should. So the course library will do that for us. It will allow requests from other origins. So an origin is this, for example. This is an origin. So 5173 is an origin, but 3000 is also an origin. So there are two different origins, and since it's not the same, it won't process the response. So let's go back to the server and fix that with a middleware. So app.use. I shouldn't put that there. Just put it here. Then require course. Wait, I'm not sure if we execute it. I think it's just that. Or just to make it more explicit, let's just do it here. Const course equals require course. So let's use course. So now my front end, please work. Loading. It's not working. Is it working? Oops, sorry. Let me check my debugger. It should send the response back because this works. Our get post should work. / get post. Why is it not sending? Oh, it's blocking the event loop. But why? Okay, let me debug this by deleting this. And let's see what happens when I do it here. It's not working again. Wait, is my server app crashed? App.use requires a middleware function. Okay, so course is not a middleware function. So is it course? Okay, I think this should work now. Okay, it works now. So my bad. Course should have been a middleware function. So this, when we require it, it exports a function. So this thing exports a function, which we have to still execute to make the middleware. So now that that works, we'll go back to our localhost. Let's go back to our application. Yep, it now responds with the proper data. So what we created so far was the get and the post. So let's check out the post. So okay, it works. So our post also works and our get also works. Very cool. So let's continue since we are now on the right track. So going back to our workflow, we check out the front end. What we need the delete post / the ID. So to implement that, let us go to our controller and let's make a function to delete a post. So const delete post equals async. So it should only take in an ID. Right? So, okay, just to make it more consistent, I'll just make it an object. So it takes in an object which has an ID, which we can then do posts.filter. So this is a lambda function. I mean, it accepts a lambda function or a callback, which will return true if we want to keep it in the array. If it's false, it will not keep the current element that we're checking in the array. So for each post, which is p, every time it is the ID that is not the ID that we passed, the ID to delete. If it's not the ID to delete, it'll keep it. So let's try checking this out right now just to make sure that our thing is correct. So console.log our array. So this should return the array except the ID that we passed, right? So let's test it out in our post routes. So we go here, the post controller, oops, dot delete post, then the ID one we want to delete. So let's say we want to delete one. So when we do this, we're going to console log the filter functions, result. So this should return everything except number one. So oops, wait, p.id, I mean. So if the post.id, because each p is an object, if the p is ID 1, it should not return it. But everything else should return back into this function. So let's see that in action. So oops, why did I go here? I'll make a request for delete post.rest. So delete, let's go here and copy our base URL. So delete / okay, let's just do that. So boom. Oops. not found post. Oops, wrong. Delete. Yep, I'm in delete post, and here is the new array that this is the console logged array. So as you can see here, it has everything except ID1. So our function is correct. So very cool. So now that we have that, wait, let me copy it. Oh, it is a array. Wait, hold on a second. Can I just reassign? Because I believe post is a reference. So if I do post, I think it's gonna fail because it's const. So I need to make it let. Wait, let me just try it now. I'm curious. My JavaScript 101 is dead. Yep. It should say const it's const. Yeah, assignment is failed. The assignment failed because it's a constant. Yep. So I need to make it let. So going back here, let's listen to the instructions of our bully to make it a let. So now it should work. Okay, so it works. So if we get posts, so let's go back to our get post request. It should not have one. Please don't be one. Oh, our one is gone. So our delete works now. Very cool. So what happens when we delete something? What do we need to respond back? It shouldn't be this. This is wrong. Does anyone know? Any knowers? What's the status code? We don't send anything. We just make a status code. So what's the status code for deleting something? Any knowers in the chat? Does anyone know what's the status code for successful deletion? 204, correct. So to do that, since we're not sending anything back, because we want to just say it's successful, we do status 204, so successfully deleted. And if we're not sending anything in Express, we chain it with .end. So end ends the response object and sends it back to the client. So now when we do delete post, this is, oops. Yeah, delete post, it's going to delete one, but one does not exist anymore. Let me just refresh the backend. We need to do error handling later. But yeah, this should return a 204. No content, yep. Then when we get again, it should return everything except one, yep, correct. So yep, good so far. So now let us handle this, the /id. So if we want to handle /id, as you can see, it's not in the body anymore. It's rather in the URL after the post base URL, right? The slash. So to handle this in Express, we need to add some spice to the string of our URL for the delete. We need to do :id. So this does express that, hey, I'm pattern matching everything that's after the slash, and we're going to be saving it in the ID variable inside our request. So when we look at request, so when we do console.log request.params, because this in web dev terms is a URL parameter, right? So in a URL parameter to extract it, we need to do request.params, which is an object that contains everything inside our URL. So everything with a dot, I mean, everything with a colon. So when you do delete again, we do /1. So wait, don't do this. Let's just show the request params object. So yep, we can see it's an object that contains whatever was matched, which is 1. So we can have as much parameters as we need here, right? Like we can match more stuff like ID, then likes /pogchamp. So when we go to this URL with the delete, so delete /likes/ whatever this is PogChamp and this is ID. So when we do that, here we go. It puts it all in the request params object. So now that is explained. Let's go back here to the ID one. So let's remove this. So that's our ID. It's in request params.id because it's an object. So let us deconstruct this params object. ID to ID equals this. So this is the ID we want to delete. So I go here, delete post and ID. Oh my gosh. So this is the cool thing of JavaScript. If your key has the same name as the value, which is a variable, we can just remove. And it's going to assign this to this. Very cool. So now when we delete a post, it's going to pass in this ID as a parameter. So as we can, let's test it right now. When we get everything, it's going to send everything back. So let's delete 4 or 3, because 3 is a more clear number. So let us now delete 3. So boom, no content, success, get all. 3 is gone. What? 3 is here? Okay, 3 is here for some reason. Interesting. So let us debug console log ID. So let's do this again. Boom, 3 is being sent. But why is my get still containing 3? Why did 1 work? Wait, let me delete 1. Very weird code. 1 is still here again? What? What did I do wrong? Delete post, post an ID. So this delete works. This should get the ID. Because I did not await it. What? Oh, it's because it's not async. Okay, that always trips me up. So 1, and 1 should not exist. 1 is still existing. Why is 1 still existing? Okay, let's debug more. Back to debugging. Also log the new array. 3, 5, 1 is still there. Why is 1 there? 1 shouldn't be there. Any knowers in the chat? No knowers in the chat because I don't know too. Okay, interesting. This is very weird. I don't know why it's not. Oh, wait. Yeah, it should work. It did work a while ago. If only I used get. Anyway, let's assume that that works. So our delete works. Ding. Let us now go to update. I'll try to fix that later. Let's go here, put. So our put, let's check out the front end again. It takes in, it sends in the title and content only, but it also sends in the ID. I know why now. Okay, because request params has a string, so the type is string, but in our code, we are checking for strict equality. The ID we're passing is a type string, but the ID of a post is a number. Oh my frick. So as you can see, let's test our hypothesis over there. So look, let's see the ID that we're passing, console.log ID type of ID. So this is sending a string. Yes, it's a string, so we need to cast it into a number. So okay, interesting. We do it here now. So now we're passing the number now. So when we go back to the controller, we're deleting the post with the strict equality ID number. So now that we do not this, 1 should disappear. 1 is gone now. Ding! So delete is good to go. We can now go into our last handler, which is put. So going back here. So it's a combination of delete, where we have to get the request params ID, and it's a combination of post, where we also get the request.body. So let's go back here to our controllers. So first of all, let's make the logic for our update. So update post. Async. Okay, actually no. Let's do the route first, because I think we can check out the contents of the arguments that way. So here we go. We do put. So let's make a request here first. So update post.rest. So it's like delete, right? So it's like delete, but we do post, and it's like create, because we also need to add this, the JSON body. So boom, we have that. That is our put. So our put request is going to go to this URL, this post ID, and it's going to set these contents. Let's see there. Oops, not found. Why? Why? Oh, because this is just slash. So I need to put ID. Yep, it's very strict. It's very exact. So now it's going to match, and it's going to get the ID variable. So we can do this. So we're extracting this, and that is our delete. So let's check out our post, which is this request body extractor. We do this, and now just to check if everything is correct, console log ID, title, and content. This should have everything that we have in our update post. So let's make our title updated title, and new fresh news, right? So see that? Yep, one updated title, new fresh news. So yep, very cool. So don't forget this is a string. So when we do our post controller, so let's now make our post controller. Okay, let's just make it more simple by just doing it all here. So here, let's call it update post, and let's have all of this here. Boom, oops. All of that, wrap it in an object. ID is gonna be a number ID. So, oh no, wait, async. So now we're going to go to post controller, update post. So, oops, no definition found because I didn't write it yet. So wait, let me remove the bloat. Here we go. So let's go make our update post. Update post is the name, right? Okay, update post is the name. So yep, it extracts these stuff. So update post equals async function. Oops. This is not valid. There, very cool. There we go, update post. Now our update post exists. We expose that. And now we're going to update. So what do we want to do here? So what's the algorithm for this? We want to run. How do we update in JavaScript again? One way is to pop it, filter it, like delete this and then update and then insert it back down here. I think that works. Yeah, that works. Okay, I'll just do that. So it's the same as this, where I post that filter. Wait, let me make the updated post. So const, so initialize updated post. Then we're going to filter out updated post. Filter out post ID to update. Then we insert it back into posts. So we're going to initialize updated post equals the thing we just have here. Wait a second, we don't need this. So it's similar to this one on top. So now we filter out the post ID to update. So ID is not equal to the ID we passed in, which is a number, because we parsed it a while ago. Then the updated post is going to be inserted back. Oh wait, we need the ID, Jed. So yeah, we need the ID. So updated post, oh no, posts dot push. We can also sort it. I forgot. I remember JavaScript has a sort. Yeah. Okay, that's too complex, but this already works as it is. But we can, yeah, further sort it so that one goes back on top. But right now, one is inserted in the bottom if we run this function. So yep, this should work. Let us try testing it out. Oh wait, we need to return something. So let's just return the update post. So we can just return to the client to just make sure that it works. So here, this should return the updated post. So yep, thank you, Prettier, for formatting my code. Console log updated post. So this should make the updated post when we do our create post. I mean, no, not create post. When we do our update post. So just checking our logic. Oh, no, let's just break something. You know, move fast, break things, fix it later. Uh-oh, async function. Why is it posting an async function? Async function, I'm awaiting it though. Interesting. So update post is the function I'm returning, but it is not running it. Okay, let's see if this works. So let's just make sure our logic works. So, oh, just another day at JavaScript land without TypeScript. Yeah, it parses the stuff and it returns the updated post once we're done. So let's see if we're returning an updated post. Oh no, I'm returning the function name update post, but not updated post. Oh my gosh. This is why you use you use TypeScript, guys. Because you'll catch those bugs really fast. Yeah, now it's okay. And now the updated post is logging it. So now let us return the status code for update. So since this is this is used for delete and update, and we return nothing. Since we're returning something, let's have an OK plus the resource updated. So now, oops, and we should make it JSON. So now let's try it again. We should get the new updated post, updated title, new fresh news. Okay, so that's good. So clean so far. So let's just test our API once again. So oops, wait, let me remove that random console log. Okay. So yeah, so this should work. Let's test the happy paths, which is all the, expecting that the data and the input and the server is in the correct state. Let's get a post. So 1 to 5. Yes, 1 to 5. So let us create a post. So this should be 6. So this is 6. So let's delete the post. So we should delete number 6 and it should delete. So no content. And when we get the post again, it should only be until 5. Yep. Update post. So when we update post, we're updating 1. So 1 should have and then there Then okay, so we're good so far. But what happens when we delete something that's already deleted? So let's say delete 6. What should happen? No content. Is that correct though? Yes, because right, we're filtering, we're checking out our database, and if it's not there, it's deleted successfully. So usually what people would think is like, if it's not there in the, we first need to search, right? And then we're going to delete if it's there. What I read was, when your intent is to delete a post with an ID, like a random ID, and it's not there, the end product is what you expected anyway. So even though it's not there, your end result is still correct, where 9 is not in the database. So this is correct. This is still correct. So how about our update? So our update should fail if something does not exist, because we expect the thing at 6 to have this. But if it's not, then it failed. So this works. So because we're inserting something, right? We're not checking if it exists. We're just inserting it directly. So that's wrong. So technically, this is not update post. This is upsert post, where we're inserting if it doesn't exist, and we're updating if it already exists. But we want this to only update post. So first, we need to just check if the post exists. So const post is exists, or let's just is exists. I'll just say that. So we'll check if posts exists. Where is it? Posts dot sum. So sum will there should be a post that has an ID, and if it does exist, if this returns true at least once, this should return true, right? Determinants callback function returns true for any element of array. Okay, that's correct, I think. Wait, let me just test it out here. 1, 2, 3 dot sum e. So e equals 1. This should be true, but if it's 6 or 7, false. Yep. Okay, correct. So that's if it exists. So if exists. If not exists, so we handle the bad things at the start. If it doesn't exist, we throw an error. Throw a new error. Post does not exist. So post with ID does not exist. Just to make it more explicit. So our async function is now throwing an error, but we're not handling it in our thingy. So this should fail and not execute when we try to update a post that doesn't exist. So boom, app crashed. So this is a problem in Express apps. If you forget to handle your asynchronous functions, your application will crash. And if this crashes and other people are using our application, they can't access your application anymore because your server crashed. And if we try to get post now, our server crashed. So yeah, connection was rejected. So we need to restart this gracefully, or we need to handle the error. Because sometimes if sometimes you just can't predict this. You can make your server restart automatically. Some cloud infrastructure does that, but in our case, let's just do it the normal way, which is we're going to handle the error inside our code itself. So when we're here in our async function, When we have an async function that might throw an error, we wrap it in a try catch, just like in other programming languages. So try, then we catch the error, then we console log that error. And just to say that since this is the client's fault that the ID doesn't exist, let's rest the status. What is the status if it's a client's fault? How do we say it's the client's fault in HTTP land? Any knowers? Does anyone know? Client's fault 400, yes, anything 400. And is it not found? Do I do not found here? I'm not sure, so I'll just do this. But yeah, I think it should be not found actually. So the thing is not found. Let's return the error back to the client. So we're making something random that doesn't exist. Oh, not found. Oh wait, why did it still crash? Updated post is not defined. Oops, sorry. Okay. Hold a minute. Oh yeah. This should return. So it should stop this callback function because without the return, it's going down and it's returning updated post. But updated post was only created here, but it failed. So we need to return here so that it stops and doesn't go here. So yeah, that's a tricky thing I got caught in before. So here now we restart. Yep, the server's running. So we do this. So yep, it's logging out the error, but it's not crashing, and it's doing not found. Uh-oh, why is this empty? So let's see here. Our error object is this. So that's our message, which we created ourselves. So I forgot what are the properties of an E. So since we forgot, let's just do object keys E. So let's see the valid things we can pass in back. Let's just do it here also. Let's do it here. So oops, why is it not there? Did I do keys right? Okay, wait, what? I think it should be a message, right? Oh, I wish I had TypeScript. I wish I had TypeScript. I'll just do this manually. Error thingy. Yeah, there we go. So e.message returns the error message. So there we go. We're returning this post with ID. That should say ID. Post with ID does not exist. So very cool. It now handles errors. So now our thing should work. So let's do happy path again. So we're going to get all the posts. OK. We're going to create a new post. So this should be 6. OK. We're going to delete, or we're going to get all the posts again. 6 is here. Hello, 6. We're going to delete 6. No content, and getting it all should not have 6. 6 is not there. When we delete something that's not existent, it should succeed because our end state should not have this, and that's true. So this is good. So our update now, so our happy path should 1. So happy path not found. What not found? Huh. Okay, so this is wrong now. So is exists. We're gonna debug again. ID type of ID. I love not using TypeScript. When is a number? That's true. Where's my sum? It's p.id. My bad. App crashed. Updated post is not defined again. Why are you doing this to me? I wait, because I'm not conning it. I should put this here, not down there. Return this. Okay, my bad. So I forgot to change that. So let's try updating a random thing that exists. So happy path. Okay. So bad path, not existent. Yep, not existent. So our backend API works in theory. Our things respond properly. So now let's check it with the front end. So right now our server is running pretty good. So now let's go check our front end. So we're now here, our front end. Oh my gosh. So we refresh. So new server, right? So oops, wait. Let me just restart the server. So back to the original state where the 5 original posts are there. So 5 posts are here. So our create post, remember earlier, worked. created post. So there we created a post. So now let's delete a post. Delete. Very good. So now let's edit a post. So SpaceX ambitious Mars plan. SpaceX scandal. Elon Musk moment. Edit. Okay, yeah. See, as you see, since we didn't sort it, it just inserts it back to the bottom. It's bad UI, but it works. So let's just fix that very quick before I stop, because that's basically our API. Our API works. And then our state is persistent. Yeah, because we have a backend. So if we refresh, it's still here. So wait, let me fix that. We'll sort it out. So let's update post. We're going to push it. Then we're going to post.sort. So going back to another lambda. So post, oh, no, this takes an A, B, right? A and B, yes, A and B. So A and B. So if post A.id is greater than, wait, no, we can just do A. I forgot how this works. If it's 1, it's greater, right? A.id is greater than B.id. So if A.id is greater than, it should return greater. If it's not, it will return the thingy. So let's do post equals that. So now when we update something, it should update in place. So crypto. Oh no, what the heck? Okay, let me go back. Go back here. 3, 2, 1. Let's start. Compare function. A and B. Haven't used this in a while. A is lesser than B. A is greater than B. MDN sort JavaScript. Hi. Oh my gosh. Okay. So 0 if they're the same, -1 if A is lesser than. Okay, I see. I see. So A is greater than. If it's greater than, return 1. If it's not, return -1. Oh, we need to catch also 0. I'm gonna make this longer. If A.id is greater than, if A.id is not equal to, if A.id is equal to B.id, will return 0, else will return this. So now this should work quite long. I think I could have done it with 1 line, but it should let us update in place now. So in place. So he's supposed to be first. Yes. There we go. Our functions worked just as we did before. So our code is done. Code is basically done. Wait, let me remove this console thing. Okay, yeah, here it is. Our thing works, and I'm going to be posting it online so that you guys can check it out. So I'll get switch. Great. Thank you, Julian, for teaching me this. So one backend array, or just call it array. So get add dot get commit feat add backend with arrays db get push origin 1 array. So now that I've pushed my code onto the internet, why is it writing a lot of objects? Am I putting the node modules? I'll check later. Anyway, if you go here in our workshop, the workshop repo, array 1 has pushes. Yep, that's what I did. Let me switch. So I'm going to check the branch. Yeah, if you go here, my code is here. If you want to check it out and work on it by yourself to experiment, it is here. I don't know why it's not loading. My Wi-Fi is pretty bad. But anyway, that should be the talk. So does anyone have any questions? Oops, what the heck? Does anyone have any questions? What? Okay, I haven't used PowerPoint. Okay, anyway, yeah. My talk's done. Does anyone have any questions? Just raise your hand or chat in the chat. We have a working backend now, guys. We went so far after a month. Or does Mary or Brian have any closing remarks or Fitz? Anything before we answer questions, the open forum?
We
Can
can
I have
have
the
that later.
PPT? Oh yeah, I'll send it later in the Discord. You're in the Discord, right, Ivan? I'll send all my PowerPoints from the previous talks that I did. But yes, I'll send it later. Voila. Did you learn a lot? I'll be asking you questions now. Oh, and some footnotes. So right now our backend is just an array. It's just this. This is very gross. This is not a real backend because it's not in the cloud. Because when our server dies and we restart it, it's going to reset the state to this. So we need to persist this by writing it to a file somewhere. And that's where databases like SAMP come in. So setting that up is going to be another beast of itself. So I just explained how Express works and how the entire ecosystem of HTTP and REST works. So that's my talk for today. So I hope you guys learned how to do that. But if you want to go beyond, you could learn, I don't know, Postgres to make your SQL database so you can connect to it and write everything to it. So you can use SQL and add stuff. If you want to set that up, you just make a Docker container for it. And then if you want to deploy this online, it's another beast of itself. Sadly, we're not going to have enough. Web Dev month is over. We're not going to have talks for that. So we're not going to be teaching about platform as a service to host your server online so that people could use it. So far, we only have a very basic front end and back end, but it's not deployed yet. Because deployment is another talk topic that hopefully we can do eventually, but not this month, or maybe not even this year. But yeah, anyways, guys, if you have questions, feel free to ask in the chat. Did you guys eat dinner already? Any knowers? Think. Brad, do you have any closing remarks? Surprisingly, yes. Very good. I did not.
Yeah, I have some closing remarks, but then we can give a few minutes for like any last questions that people might have. We can give them until like 9:40 to ask questions. And if none, then we can proceed to the closing remarks and then photo op as well.
All right. One more minute. If no questions, we're gonna proceed. Okay, anyway, just to share where we are so far in the roadmap. Full stack. Roadmap. Let's check out where we are in the roadmap, because in Web Dev Month, we went to HTML, CSS, JavaScript. We went to NPM, and thanks to Julian and John, we had Git and GitHub. Then last time we had React. Tailwind, not really, but I'm using it. It's something you could learn on the side. Node.js, I talked about that today. And this is what I was talking about databases for keeping state. So we stopped here. Oh, technically RESTful APIs also. But yeah, after that, you have a long road to go. So we're halfway in 1 month. So I guess no one has any questions. Can have the closing remarks now. I'll stop sharing.
Oh yeah, sure. So yeah, guys, if you don't have, I mean, if you guys do have any questions, feel free to just message in the Discord. Tech team is always, I mean, I wouldn't say we're always active there, but then we check from time to time. So just feel free to leave your questions. Oh, Mary's here, guys. Is it okay if you can do the photo op, Mary? But yeah, before we do the photo op, yeah, just want to thank you guys for joining us for the web dev workshop series. This is officially the last one of the year. After this, we'll be resuming the workshops in February or January, and then our next the main content of that will be game development. So you guys, hopefully you guys are looking forward to that as well. And yeah, besides the workshops, the tech team is also cooking up other activities, but then they're probably just gonna be in the Discord. They won't have any like formats for it because it's easier to set up. So yeah, just keep your eyes posted on the Discord as well. And yeah, that's it. Thanks for joining, guys. And then Mary, you can do the photo op now.
Okay. Yo, guys. All right, so turn on your cameras, please. Oh, guys, turn on your cameras for the photo op. Done. Are you still gonna have the together mode thing? At.
Yeah, we can have both.
Fizz, let's make a heart.
Wait, where are you? Wait, I don't see you.
That's just like,
The together one's not yet here.
yeah.
Oh, it's there.
Yeah, way up.
You're above.
Oh,
Yeah.
oh yeah. Oh no, man. How do we do this?
Is there
Why
like
am
a
I
way
so
you can
small?
switch panels? No, you can, right? No, you can't switch panels. Never mind. Come on, guys, turn on your cameras. It's the last one.
Oh my god, my fan. Wait, Mary, how about you and me? Oh, dude, what is
No,
this? It's so scuffed.
we're far.
Oh no. Dude,
Hey,
How are
you
you so
Mary.
big?
and Ryan are next to each other though.
Yeah, but look, I can't touch the next dimension.
Wait,
Wait,
can I
Brad,
reach
like,
you? Oh no.
I'm gonna pass you my comb. Catch it.
Oh my god.
Oh.
What are you doing?
That's how you pass by copy, guys.
Oh my gosh, you nerd.
But you implemented Jixtras earlier.
No, but like, but like, it won't pass this one stupid test case. It's fine. It works.
Turn on your cams, guys.
Yeah, come on,
The
guys.
last.
Your cameras
The last photo op of the year.
of the year, actually. Last photo off before finals and stuff. Okay.
Or we
Wait.
retake DSA.
Sibakol na,
Yeah.
no, retake. Uy, sibakol.
Hey, before we one take DSA.
Yeah, one take.
Sure, Mary.
Hold up. Wait, I have a problem. Like, I don't know what it is, but I can't see, large gallery.
Really?
Yeah, I don't know why.
Oh, because we're only 17 people.
Oh,
There's no
There's
one
a
to see.
I didn't know that. My bad.
It's
Hello,
okay, we're in
Zach.
the jungle right now.
I'll take a photo by 9:45 because I'm also trying to. Yeah, I can't get everyone in photo like for gallery lang
Wait,
because
let me
of.
try. Wait, maybe there's a limit to how many people can join the scene thing.
I think it's just us.
Yeah, could be as well.
Yeah.
But I guess that
Yeah.
Violet Eyes guy is also a GDSC lead
Sure.
Oh, yo.
from Holy Name University.
Oh shit, that's
Oh,
Oh,
Violet
yo, I
Eyes.
remember
Yeah.
that talk. I
And his name
remember
is
the
Zach.
last talk.
Oh yeah, that talk. Oh my god. Yeah, it's that one.
The real
Yes,
nickname was like Violet Eyes or something.
Oh my gosh, I thought it was Viva. Oh my god. Okay, it's 9:45 right now. I think like if there's something we can do about the gallery, hello, then we can just I don't know. Can we just do it together mode photo? Cause like I really I see large gallery. Never mind. Thank you, thank you, thank you. It's here.
Because I think large gallery is only enabled if 9 people have their accounts on. So I guess.
So it's something you had to like manually change the preferences. Okay, Siggy. Alright. Alright guys, turn on your cameras and let's take a photo. So yeah, this is the last time we'll be doing it for this month and for the web dev division as well. Pretty sure. So yeah. Alright. So sige. Alright. In 3, 2, 1. Alright, let me just save this photo. And then, is it okay if everyone does the GDSC posts as always?
That's the login.
Test the login. What? Okay, sige. In 3, 2, 1, GDSC post. Alright. And then one last for the
Where are
together
my
mode.
fingers?
Let's heart. Come on, come here.
Don't reach.
Alright, try now.
Oh,
Oh, you can, you can, you can.
Oh.
It's
Let's
almost
go,
there.
let's go.
Move down.
That's adorable. Okay,
My
okay.
thumb.
Alright. In 3, 2, 1. Alright.
No, it's so
No.
bad.
Thank you so much, guys, for coming. Thank you, everyone, for coming to the last workshop for a while when it comes to web dev, and as well as for this semester, I'm pretty sure. So yeah, I hope everyone has a great time. I hope all of you guys learned so much today. I'm sure you guys learned a lot. Ian literally like demoed so much today, and we literally learned so much. So yeah, just a reminder once again. Um, Oh, thank you. Thank you. But yeah, just a reminder once again for people who are interested in data science, heads up lang during December time, we will be having announcements. So for those of you who are a little bit more interested in that, in that side of the tech industry, then make sure to check out GDSC's Facebook page this December. And yeah, so for any links that were dropped a while ago and for the recordings, just make sure to check out the Discord, guy. We're gonna pop it up later. So yeah, thanks so much, guys, for coming. Hope you have a great night. Bye
Thank you,
bye.
guys.
Thanks, guys. Thanks, Mary. Thanks, team.
Thank you. Thanks, Ian.
You.